Okay. So, if we're asked to draw an angle in standard position, we need to start on the positive side on the x-axis, and then we go counterclockwise. If we're given a negative one, we go clockwise. If I have my angles in degrees, I'm going to start at 0 degrees, and then it goes 360. No. I mean, 360 will be there. It comes at the end. Because 360 is a complete circle. Then I have 90 degrees, 180, 270, and then finishing up the circle would be the 360. Okay, then I could do the same thing with my negative degrees. So I would have 0 for negative, my negative starting point. Then I have negative 90, negative 180, negative 270, and this one will be negative 360. So negative angles go negative go clockwise, positive go counterclockwise. And they both start at the positive x-axis. Okay. Then we also have 4 quadrants. They start in the top right, and then they also go counterclockwise. It goes 1, 2, 3, 4. And then depending on what quadrant it is, the x and y values change signs. So number 1 wants me to draw an angle with the given measure in standard position and then state what quadrant the angle is in. So I have 240 degrees, which is between 180 and 270. So I'm going to draw that in quadrant 3. And then I also draw a line to show where it started and where it ended. So this one is quadrant 1. And typically the quadrants are written in Roman numerals. Then I have 500 degrees, which is more than my 360. So what I want to do is I want to start by subtracting 360. Then this will give me 140. So 140 is between 90 and 180. It's going to be here. And then when I draw my arrow for my direction, I'm going to make a complete circle because I've gone around once and then I end it. Kind of like a spiral. Number 3 gives me the negative angle, so I'm looking at my red angles for this one. It's negative 50, so that's between 0 and negative 90. That is in the 4th quadrant, and because it was red, I only just moved over a little bit. I forgot to say this one. This one was quadrant 2. So I want to do the same things for 4 through 6. On number 4, it is more than 360. Yeah, more than 360. So I want to go ahead and subtract 360. This will give me 30, which is between 0 and 90. So when I go to draw it, I make one complete circle around and then end back. This one puts this in quadrant 1. This one was quadrant 3. I don't know why I said 1 earlier. On the second one, this is negative, so I'm going to look at my red degrees. This would be between negative 90 and negative 60, which takes me here. This one is quadrant 3. Number 6 is also greater than 360, so I want to go ahead and start off by subtracting 360. This will give me 330. So that is between 270 and 360. Since I subtracted, it goes around more than once. And this gives me quadrant 4. Then you might have learned this last year in geometry. You might not have, depending on what your teacher taught during the pandemic. But if we are going from degrees to radians, radians are another way to measure angles, and you typically see these in higher level math courses. You want to take the degree amount and multiply it by pi radians over 180 degrees. This is because there are 360 degrees in a circle and 2 pi radians in a circle. We simplify the fraction to get pi and 180. If I'm going the other way around and I want to turn radians into degrees, I just flip the fraction and have 180 on top. So I like to think about it as if I have a pi, then I want the pi on the bottom to cancel out. So if I take a look at number 7, this one wants me to, depending on what I'm given, either convert to degrees or convert to radians. I have the degree symbol. So when I'm going from degrees to radians, I want to have pi over 180. And if I'm going from radians to degrees, I want the 180 over pi. So I have the degrees to start off with. I'm going to multiply by pi over 180. Then what I can do is I can rewrite this fraction so I have just the numbers together, bless you, and the pi off to the side. So then I can go to Desmos and simplify this. So I can do 120 divided by 180. Remember, under the 1, if I click the box over the box, it turns it back into a fraction for me. So I get 2/3, and this will give me 2/3 pi. Okay. Number 8, I have a pi already, so that means I'm in radians. So I want to use the second fraction, the 180 over pi. Then I want to go ahead and, because I have a pi on the top and bottom, those cancel out. So I'm left with 180 on top, negative 12 on bottom. So I can go to Desmos and simplify this. I wasn't even typing. 180 divided by negative 12. This gives me negative 15. So this would be in degrees. So on number 9, I have it in degrees first, so I'm going to multiply by pi over 180. I can go ahead and rewrite this as negative 150 over 180, and then the pi. If I go to Desmos, I want to do negative 150 divided by 180. Turn it back into a fraction. This gives me negative 5/6. Then on number 9, I have a pi, so this means this one's already in radians. So I want to multiply by 180 over pi. Then my pi's will cancel out. So I am left with 9/4 times 180. I can go ahead and go to Desmos. Which gets me 405. So my answer here is 405 degrees. The last thing we're going to talk about is the arc length of a circle. Basically what this is the circumference formula, but only for a portion of the circle. So an arc, remember, is only a little bit, so like right here. The formula is S equals R theta, where S is the sector length, R is the radius, and theta is the angle in radians. So I want to make sure I have that pi here when I'm doing these problems. This one tells me a softball field forms a sector with the dimensions shown. Find the length of the outfield fence. It's hard to see, but it has a box here, and it says it's 90 degrees. So what I want to do is I first want to convert my 90 degrees to radians. So I'm going to take the 90 times pi over 180. Then I can rewrite this as 90 over 180 pi. I can go to Desmos and figure that out. 90 over 180 is a half. So I have 1/2 pi. This is my theta that I'm going to be plugging into this formula. If I look at this, remember, if I have a circle in general, all the way across is called a diameter. And halfway across is called a radius. So, just in case you need to know it for the homework, diameter equals 2 times the radius. In this picture, the 200 is my radius. So all I need to do is plug into this formula. I'm going to have S equals, my radius was the 200. My angle measure was 1/2 pi. The problem doesn't say it, but the test will. I want to leave in terms of pi. So all I need to do is multiply the 200 by the 1/2. So if I go to Desmos, 200 times 1/2 gets me 100. So my answer here is 100 pi. Okay, so on number 12, it's the same picture as number 11, so that means it's the same angle. So my theta is, again, 1/2 pi. This time it tells me my radius is 180. And I need to find the length of the outfield fence. So what I'm going to do is I'm going to do S equals, my radius is 180, times 1/2 pi. Then I just need to multiply 180 by 1/2. Which gets me 90 degrees. Not 90 degrees, just 90 pi. Pi is part of my answer here.